this episode, we take a step back from individual AI controls and look at how auditors can use data to see the bigger picture of what is really happening over time. Many beginners assume auditing is mostly interviews and checklists, but modern environments generate so much activity that patterns become visible only when you look at the numbers across weeks and months. Analytics is the bridge between lots of small signals and a clear story about risk, because it helps you detect when a system is slowly changing, when something unusual is happening right now, and when controls that look fine on paper are actually weakening in practice. The goal is not to turn you into a data scientist, and it is not to make you memorize math. The goal is to help you understand how an audit mindset uses evidence at scale to find drift, spot anomalies, and identify trends that suggest control breakdown before customers or executives are forced to learn the hard way. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Analytics, in an audit context, means using data that already exists in systems to answer questions about behavior, risk, and control effectiveness. It includes simple things like counting how often events happen, comparing this month to last month, and looking for spikes, gaps, or shifts in patterns. It also includes more structured approaches, like measuring error rates, tracking how frequently humans override AI recommendations, or monitoring how long it takes to respond to incidents. When we say artificial intelligence, AI, here, we are talking about systems that make predictions, classifications, or generated outputs that influence decisions. Those systems create logs, metrics, and records, and those records are raw materials for analytics. The audit value comes from being consistent and skeptical, meaning you define what normal looks like. You look for meaningful deviations, and you ask what those deviations imply about controls and risk. Even basic analytics can be powerful when it is connected to clear questions and interpreted carefully. To use analytics well, you first need to understand the difference between a single event and a pattern. A single strange output from an AI system might be a one-off, but a pattern of strange outputs suggests a systemic issue that deserves investigation. A single delayed response to an alert might be caused by a busy day, but a trend of growing response times can indicate that incident handling controls are weakening. Analytics helps you move from anecdotes to evidence, and it also helps you avoid being misled by unusually good or unusually bad days. A beginner-friendly way to picture this is to think about a thermometer reading. One high reading might be a fluke, but a week of rising temperatures tells you something real is changing. Auditors care about patterns because controls are meant to work reliably over time, not just during a demonstration or a special inspection window. Drift is one of the most important patterns to detect because it often appears gradually and quietly. Drift means the system's behavior is changing because the data, the environment, or the real-world meaning of inputs is changing. The model may start seeing different kinds of customer requests, different transaction types, different language, or different attacker behavior, and that can shift outcomes even if the model has not been intentionally updated. Analytics can detect drift by comparing current input distributions to prior ones, comparing key performance measures to baselines, and tracking whether the model's confidence or error patterns are changing. The audit mindset here is to treat drift like a predictable risk that should be monitored, not like an unavoidable surprise. If an organization claims its model is stable, but the analytics show a steady shift in inputs or outputs, that is a signal that monitoring controls may be incomplete or that the system may need review and adjustment. When you look for drift, baselines are essential because you need a reference for what normal looked like when the model was considered acceptable. A baseline might be performance during a controlled validation period, performance during the first month after deployment, or a rolling average that updates over time. The baseline you choose should match the business reality because seasons, product changes, and external events can naturally shift behavior. For example, customer service requests might change during holidays and fraud patterns might change during major shopping periods, so the baseline needs to account for expected variation. Auditors evaluate whether the organization set baselines intentionally and whether they understand normal volatility versus concerning change. Drift analytics also needs clear thresholds or decision points, because noticing drift is not enough if no one knows when drift becomes a problem that requires action. A good control environment can show how drift signals lead to investigation, mitigation, and, if needed, model updates or restrictions. Anomalies are different from drift because they are about unusual events or sudden changes rather than slow movement. An anomaly might be a sudden spike in a certain type of output, a burst of requests from a new source, a sharp increase in errors, or a sudden drop in the system's ability to respond. Anomaly detection can be as simple as setting alerts when a metric crosses a threshold, and it can also involve comparing current behavior to historical patterns for the same time of day or day of week. For beginners, the key is to remember that anomalies are clues, not conclusions. A spike might indicate misuse, an attacker probing the system, a broken data feed, or a new legitimate business activity that has not been accounted for. Analytics helps you find the anomaly quickly, but auditing requires you to connect it to evidence and assess whether controls responded appropriately. If anomalies happen frequently without investigation, that suggests alert fatigue or weak incident handling controls. A useful way to frame anomaly work is to ask what the anomaly threatens. Some anomalies threaten security, like unusual access patterns or repeated attempts to cause harmful outputs. Some threaten quality, like sudden increases in nonsensical results or inconsistent recommendations. Some threaten compliance, like unexpected logging of sensitive data or sudden changes in how data is retained. When you tie anomalies to threat types, you also tie them to the relevant controls, such as access controls, monitoring controls, incident response controls, and data governance controls. This is where analytics becomes audit grade, because it stops being a technical curiosity and becomes evidence of how well the organization manages risk. Auditors also pay attention to timeliness, meaning how quickly the organization noticed the anomaly and how quickly it responded. A great control design on paper is not effective if the organization regularly discovers anomalies days later from customer complaints. Control breakdown trends are the third focus, and they are about the health of the control environment over time. A control breakdown does not always look like a dramatic failure. It can look like small increases in exceptions, small delays in approvals, more frequent overrides, or a rising number of unresolved alerts. Analytics can show those trends by tracking control-related indicators, such as how often required reviews are skipped, how often model changes are rushed, how many policy exceptions are granted, or how frequently humans reverse automated decisions. For beginners, it helps to think of controls like safety rails on a road. If the rails are gradually being removed to speed up construction, the road might still be usable for a while, but risk is rising in a way that is hard to feel day to day. Trend analytics turns those small changes into a visible signal that leaders cannot easily ignore. In audit terms, trends help you identify where controls are eroding and where intervention is needed before a major incident occurs. One of the best indicators of control health in AI systems is the relationship between automation and human intervention. If the organization expects that humans will review certain cases, then the rate of review and the quality of review are control signals. If analytics shows that review rates are dropping or that review decisions are being rushed, that may indicate staffing issues, process friction, or increasing workload, all of which can weaken controls. Another indicator is the rate at which the system triggers escalations, because a sudden increase might signal instability, while a sudden decrease might signal that detection has been disabled or that thresholds were loosened to reduce noise. Auditors do not assume that more alerts are always worse or that fewer alerts are always better. Instead, they look for explanations that align with evidence, such as changes in usage, changes in policy, or changes in model behavior. Analytics supports that reasoning by providing objective measures that can be compared across time periods. To make analytics trustworthy, data quality matters, because poor data can produce misleading conclusions. Logs might be incomplete, timestamps might be inconsistent, or metrics might be calculated differently after a system update. If you compare 2 months of data but the organization changed how it measures errors halfway through, a trend might appear that is not real. Auditors therefore evaluate the reliability of the data sources, including whether logs are consistent, whether definitions are stable, and whether changes to measurement are documented. This is not a request for perfect data, but it is a request for honest data. A mature organization can explain the limitations of its metrics and still use them responsibly, while an immature organization uses shaky numbers to claim success or to deny problems. Beginners should remember that analytics is only as good as the definitions and collection behind it. So audit skepticism includes verifying that the measurement itself is controlled. Another key concept is segmentation, which means breaking data into meaningful groups so patterns become clearer. If you look only at overall averages, you might miss that one product line is failing while the rest is stable, or that one region has a higher rate of harmful outcomes, or that one customer segment is being impacted unfairly. Segmentation can also separate normal changes from concerning ones, because different groups naturally behave differently. For example, nighttime traffic might have different patterns than daytime traffic, and new users might interact differently than returning users. In auditing, segmentation helps you avoid being fooled by aggregation that hides pockets of risk. It also helps you create more precise findings, because you can point to where the problem is concentrated rather than making vague claims about the whole system. Analytics becomes more actionable when it can say not only that something changed, but where and for whom it changed. As you connect analytics to audit work, it is helpful to think in terms of questions rather than tools. A strong audit question might be whether the model's error rate has increased in a way that correlates with a shift in input data. Another might be whether the rate of policy exceptions has increased after a schedule change in the review team. Another might be whether incident response times are trending upward during weekends, suggesting a coverage gap. These questions are powerful because they connect business impact to control design and control operation. Analytics provides evidence to answer the questions, but the auditor provides the judgment about what the evidence means and what risk it implies. This matters because AI environments can produce many metrics, and without good questions you can drown in numbers without learning anything useful. The audit mindset stays focused on risk, control effectiveness, and the real-world outcomes that stakeholders care about. It is also important to understand that analytics should support, not replace, professional judgment. Numbers can point you toward areas that deserve attention, but they do not automatically tell you why something happened or what should be done next. For example, a trend of increasing overrides might mean the model is drifting, but it might also mean the business changed its policy and humans are applying new rules that the model does not yet reflect. An anomaly in usage might indicate an attack, but it might also indicate a marketing campaign that drove new demand. Auditors validate interpretations by gathering additional evidence, such as change records, approvals, incident tickets, and stakeholder explanations, and then checking whether those explanations match the data. This is where audit-grade skepticism lives, because you do not accept a story simply because it sounds reasonable. You test it against evidence. Analytics is the spotlight, but verification is the discipline that keeps the spotlight from becoming a stage light for performance. When analytics reveals drift, anomalies, or control breakdown trends, the next step is understanding what a good response looks like. A good response starts with triage, meaning confirming whether the signal is real and whether it represents meaningful risk. It then moves into investigation, where the organization identifies contributing factors such as data changes, recent updates, unusual user behavior, or failures in monitoring. It then moves into remediation, which could include tightening controls, retraining or updating the model, adjusting thresholds, improving data validation, or changing the operational process around the model. Auditors evaluate not only whether the organization can detect issues, but whether it can respond in a way that reduces risk over time. If the same anomalies recur repeatedly with no lasting improvement, that suggests the organization is treating symptoms rather than fixing causes. Analytics helps reveal that cycle because it shows whether interventions actually change trends. A final piece that beginners should keep in mind is that analytics is most valuable when it is continuous and comparable across time, because the purpose is to detect change. If an organization only pulls data during an audit, it misses the opportunity to catch issues early, and it also makes it harder to know whether the audit period was typical. Continuous analytics, supported by stable definitions and consistent collection, creates a history that can be reviewed and learned from. It also supports accountability because teams can see whether control changes improved outcomes or whether risk is quietly rising. In AI governance, that historical view matters because behavior can change without obvious triggers, and because slow drift can create harm that accumulates. Auditors use trends to separate random noise from meaningful movement, and that ability is a core skill in modern assurance work. The stronger the analytics foundation, the more confident an organization can be in its control claims. Using analytics to detect drift, anomalies, and control breakdown trends is really about learning to read the organization's behavior through the evidence it produces every day. Drift signals that the world is shifting under the model. Anomalies signal that something unusual needs attention now, and breakdown trends signal that controls may be weakening even if no single event seems dramatic. Analytics makes those signals visible, but auditing makes them meaningful by connecting them to risk, control expectations, and responsible action. Along the way, you rely on baselines, reliable data, thoughtful segmentation, and clear questions to avoid being misled by averages or noise. You also keep professional skepticism at the center, using the numbers as a guide while still validating explanations and outcomes. When you can do that, you are not just collecting metrics. You are building a defensible view of whether AI controls are working over time and whether the organization is learning before harm forces it to learn.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.